Yeah, good morning, students. In the previous class, we discussed about how the performance of a processor will improved by making use of different types of methods like instruction parallelism, multi-core processor systems, and multiple processor systems through shared memory concept as well as through message passing or message communication mechanism. We can improve the parallelism or execution speed of a processor. Now, today I would like to discuss about the concept of memory locations and how the addressing mechanism is used. So now I would like to share my screen. So I am sharing my PPT. So the topic for discussion is so memory locations and addresses. So the lecture objectives are how the memory is organized in the computer. So how the memory is organized in the computer in terms of cells, and how we can make these cells to form a word, and how the main memory can be addressed using these words. So that we are going to learn in today's classroom discussion topic. So generally the main memory in the computers, okay, so in the main memory, generally we can view this main memory within the computer as an array of cells, collection of cells. Like this we can view that each individual cell, so this is one cell and this is another cell, like that we can view this memory in the form of millions of cells. We can view that storage cell, we can call it as, and each cell is capable of storing a one bit of information, either 0 or 1. So this cell is able to store either 0 or 1, and this cell is able to store either 0 or 1, and so on, like this. But when we want to handle each cell, it is a very difficult task. So that is the reason what we will do here is that we will group these cells. We will group these cells to form a word. To form a word. So this how do we group these cells? Generally, 8 bits we can group to form one byte. Okay, just like 4 bits. So what is the 4 bits? If you group 4 bits, what it is called? What it is called? So it is called it as one nibble. 4 bits is called it as one nibble, and 8 bits we call it as one byte. Okay, so like that we have 1024 bytes. We can call it as 1 kilobyte. So like that we are grouping the memory cells so that we can access the information. We can address these memory cells by making use of this word. Generally the word length. So nowadays in our computers we are making use of this word length. So generally typically it varies from 16 bits to 64 bits. So a word length of 16 bits, so that is 2 bytes Okay, a word length of 64 bits, that is called it as 8 bytes. So like that, here we are taking this word length ranging from 2 bytes to 8 bytes. So if the word length of a computer is having 32 bits, that means a single word can store. So we are taking a single word whose length is equal to 32 bits. That means we can store a 32-bit signed numbers we can store into this one word, or 4 ASCII characters we can store in this particular one word, because each character occupies 8 bits, so we can store 4 characters into this single word of 32 bits size. So this depends upon the computer to computer. So we are making use of this word length. So based on that word length, so we are making use of this distinct names or addresses we are using for each location in the main memory. So it is customary to use the numbers from 0 to 2 power k minus 1 for some suitable value of k. That means here how many memory words we are taking here, how many bits we are taking to form a memory word. Based on that, the memory can have up to 2 power k addressable locations. So the 2 power k addresses which constitutes your address space of the computer. Okay, so generally that we will see that, for example, if we have a 24-bit address generates 24-bit address will generate 2 power 24 memory locations, different memory locations. So if we have generally a word length of 24 bits, so we may have 2 power 24 memory locations. So that 2 power 24 memory locations, which we are calling it as memory address space, which we are calling it as. So this 2 power 24 locations, so generally we will write it as 16M, that is 16 megabytes of locations we are generating that, because 1 MB is nothing but 2 power 20. Okay, so it is approximately 2 power 24 is approximately here. Okay, we are taking it as 16M, we are taking it as. So that is what our memory address is basically. Similarly, if you take a 32-bit address, okay, if you take a 32-bit address, so if you take that, so 2 power 32 are the memory locations that are going to be created here. So that is your entire address space. So where we are calling it as 4G locations we are going to get. Okay, so 4G is nothing but where 2 power 30 is called it as 1 gigabyte. Okay, 1 gigabyte is nothing but 2 power 30. So 2 power 32 is nothing but here we are going to get it as 4G locations we are going to get if your address uh, is having 32-bit length. So if your memory address is having 32-bit length, so you are going to get the entire address space of 4G address space we are going to get. So this is how we are diagrammatically representing here basically. So you take n bits, okay, n number of bits here, like this we have n number of bits. Okay, so we are forming or we are grouping this n number of bits as a word. So if you are grouping this n number of bits as a word, then this is the first word, and this is the second word, and this is the third word. Like that we have this is the eighth word in the memory address space, and like this here we are going to get 2 power n minus 2 power n minus 1 number of address locations we have in this address space, so which is called it as your memory address space. This is what memory address space, your entire memory address space. So that is what we are calling here. So if you go to the previous slide here, so if you are taking 2 power 24 bits, you are taking that, that means 2 power 24 is the total address space we have taken, where you can uh, get it as 0 to 2 power n minus 1 different locations. So memory addresses we are getting that. This is address 1, this is the second address, and so on. This the third address, and this is the ith address we are going to get. Like that here. So 0 to 2 power n minus 1 total number of addresses we are going to get. So the address space you can take it as 0 to 2 power n minus 1, that is nothing but 2 power n is your total address space which it is consisting of. Okay, so that is what the different address space what we can get it as. So this already we familiar with that. A byte is always consisting of 8 bits, but the word length is typically the word length is typically range from 2 bytes to 2 bytes, that is 16 bits, means that 2 bytes. So 2 bytes, this is the 2 bytes to what we can call it as here 8 bytes. So your word length is basically range from 2 bytes to 8 bytes. So the most practical assignment here is that we have the successive addresses, so which refers to the successive byte locations in the memory. So that we have seen here. So these are what we are calling it as, this is word 1, this is word 2, like that we have the successive word locations are there. So now in modern computers, generally we are making use of this byte addressing only we are using here. Okay, byte addressable units we are using, because based on this word length, typically we are making use of this byte addressables locations we are using that. So the addressable locations having the address 0, 1, 2 and so on, we have 2 power n minus 1 addresses we have here. So when we have the byte addressable locations, so how we can assign these words, so in that particular byte addresses. So there are two ways here that the byte addresses can be assigned across the words. So just we have taken earlier, we have taken this is a word, we have taken that. So if a word is having 16 bits length, then we have 2 bytes will be there. So if a word is having 3 bytes or 4 bytes, then we have this 4 bytes will be there. Now how you can address or how we can store, this is a one word, we can call it as memory word. One memory word we can call it as, in this memory word, so this is byte 0, this is byte 1, and this is byte 2, and this is byte 3, for example. This is a 4 byte addressable memory word. Similarly, if you take this a 2 byte memory addressable word, so this is a byte 0 and this is a byte 1. So this is one memory address or one memory word if you take it as. So having 16 bits, and this is a memory word having 64 bits length. So in this, how we are storing these bytes, how we are ordering these bytes, that is what we are calling it as a byte ordering. So there are two ways to order this particular bytes. So like this, you are assigning the byte 0, byte 1, byte 2, byte 3, that is from uh, left to right you are assigning that. So there is another way is also there. So you can assign the bytes like this B0, B1, B2, B3, that is from right to left direction you can go. Okay, this is from left to right to left direction, and this is left to right direction. So left to right direction we are ordering the bytes, and here right to left direction we are ordering the bytes. So these are the two ways of ordering of the bytes across this memory word. Okay, so these two which we are calling it as big Indian and little Indian representations basically. So if you take this big Indian, this is what we are calling it as, the first diagram shows this big Indian way of assigning the multiple bytes in the memory addresses. So this is the memory address 0, like this if you take it as, so the byte addressings will be like this. So byte 0, byte 1, byte 2, byte 3, and then byte 4, byte 5, byte 6, byte 7, and so on. Like this we are assigning the uh, bytes, multiple bytes in a memory word like this. So that is from left to right direction we are moving, we are assigning the bytes in the memory words. So this is called it as a big Indian representation. And whereas here if you are moving this assigning of the bytes, this is B0, byte 0, byte 1, byte 2 and byte 3. and byte 4, byte 5, byte 6, that is from right to left if you are moving that. So then this way of assigning the multiple bytes, which we are calling it as a little Indian method of assigning the uh, bytes in a memory word. So these are the two different types of representation of the bytes in a memory word. Okay, big Indian and little Indian way of representing of these bytes. So the name Big Indian is used here when the lower byte addresses are used for the most significant bytes. So that is the leftmost bytes of the word. Okay, and the name Little Indian is used for the opposite ordering here, where the lower byte addresses are used for the less significant bytes of the word. Okay, so the more significant and less significant are used here in finding the relationship of between these particular weights. Basically, that is 2 power is assigned for this particular bits when the words are represented in a memory. So both little Indian and big Indian assignments are used in all these commercial computer systems. So some computer architectures will follow the big Indian notation of assigning the words in memory, multiple words, bytes in memory words, and little Indian format is also be used in some computers basically. So in both the cases, the byte addresses are 0 and 4, 8 are taken as the addresses of the successive words in the memory. So if you take here what we are calling it as here, this is 0 is the first word address, and 4 is the second word address. This is the word one, first word, and this is the second word, and this becomes 8 here. This is the third word address. Like that here, 2 power k minus 1, it represents the kth word in this what we can call it as a big Indian representation. Similarly, here also in the little Indian, also here the 0, which is used in the uh, zeroth location here, how we are assigning the words in the right to left direction. So where we are using here 2 power k minus 4. Okay, so this is the kth word in this memory. Okay, this is the first word and this is the second word and so on. So like this we are making use of this both big Indian and little Indian representations for ordering of the bytes in a um, memory word of a computer basically. So that is the most significant and least significant bit locations how we are assigning the words. Based on this little Indian and big Indian, they will be differentiated how we are making use of this byte addressings we are using in this computer. Fine. So upon completion of this today's discussion topic, so the lecture outcome is that you can understand how these memory locations are addressed and what is the memory address, and what are the two different ways of byte orderings that we can use in a memory one. Fine. So thank you for watching this video. So thank you one and all.